What else would Gus Hansen be raising you $165,000 with? And Daniel decides to call.
Shows in the fives.
You had one out.
I believe you. I believe him.
Wasn't too happy. Meanwhile, he rakes in the pot over $175,000.
You're looking at a man who just lost almost $300,000 cash.
So here's a summary of the odds. 1 in 100, 1 in a billion, 1 in 1,000, 1 in 100,000. One thing I want to point out, those top two, the top quadrant is the Ingrams being a liar. So mind you that, okay? So that one I'm getting the most leeway to. So here's how we're going to score the odds. Option 3 means at least one of the premise of each of the paradox is incorrect. There's 4 ways we can put this together. We can have 1 and 3, 1 and 4, or we can have 2 and 3, and 2 and 4. Now, mind you, the top two here that are listed are include Brian Ingram and the Ingrams themselves being liars. So I'm sure Brian Ingram himself would give that a 0% chance, in which case you would have a 0 times 1 in 1,000 and 0 times 1 in 100,000. But in this case, we're just going to say a 1% times those numbers. And then the second one involving number 2, which is the landing area, 1 in 10 to the 9th times 1 in 1,000, 1 in 10 to the 9th times 1 in 100,000. So what's this wind up being when you multiply those out? Well, the odds that 1 in 3 were errant is 1 in 100,000. The odds that quadrants 1 and 4 are errant is 1 in 10 million. The odds that 2 and 3 are errant is 1 in a trillion. And the odds that 2 and 4 are errant is 1 in 100 trillion. We're talking about some astronomical numbers there. Frankly, 1 in 100 trillion, I have a better chance of playing the lottery with $1, okay, and putting it in my pocket, and the winning number is getting drawn as I'm hitting a hole-in-one on a golf course, and then a bolt of lightning strikes my club. Okay, that's the kind of ridiculous odds we're talking about. So maybe I was being a little too harsh. You know, maybe I'm just arbitrarily assigning some really tough numbers here that are tough to beat. So let's assume now that we'll just take the easiest of all 4 of those and say each quadrant has an equal amount of probability of error, 1 in 100. I'm being very generous with this, but here's what it's going to look like. You're going to have 1 over 100 squared, which winds up being 1 in 10,000 for each of the 4 ways to solve this. Mind you, the top 2 are the Ingrams being liars, so Brian Ingram probably has to just strike those out. But I don't know if he is or not. So you have 4 of them. When you do the math, it means you need to add all 4 of those odds together. And what you get in the end is 4 out of 10,000 chance. So what does this mean when you narrow it down to a understandable number? It means that option 3 has a probability of 1 in 2,500. Option 3. So this is what these guys have been chasing, odds of 1 in 2,500. And remember, I'm being generous with those quadrants. So here we have a lineup, such as you see if you ever watch poker on ESPN. They have the card hands, and they tell you what's likely to win. We don't know what the opponent's holding, option 1 and 2. We know what we're holding, option 3. We know that it has a 1 in 2,500 chance. So what does our opponent hold? A 24.99 over 2,500 chance. Oh, well, what's that mean in percentages? Well, I'll show it to you. It's 99.96 versus 0.04. Mind you, that 0.04 could be halved if you want to remove the Ingrams as liars as a possible solution. I decided to make a pie chart, even though, frankly, it's kind of foolish. But you'll see here the little slit there the little slit there hanging down is about the size of a piece of paper, and that's your probability on a pie chart. Okay, and actually, let me give you a better visual. If you were to take, well, on average, 4 Bibles, and you stacked 4 Bibles on top of each other, okay, and then you left the room, and I were to tear a page out, okay, stick it in my pocket, and you were to come back in the room, and I said, now, I want you to randomly guess what page I tore out. And you have to pick which Bible and what page. That's the kind of probability we're talking about. Your average Bible has about 600 pages. Well, 1,200 pages, but 600 sheets. Okay? So let me put this into perspective in real life and give you an example of what this actually means. A card counter's edge is only 1% in a casino, and yet a casino will engage in what's known as countermeasures. Okay? They'll apply heat, they'll backroom a guy, they'll kick him out, they'll make him flat bet. And as extra credit, I want you to tell me, if you can tell me who this gentleman here is pictured, I'll give you a hint. He got his undergrad degree at the same university that Leonard Palmer, the geologist, was a professor at. Okay. Also, to put this in perspective, an average casino edge is less than 10%, and yet there's a big city in the desert that thrives off this edge. So your average gambler faces a disadvantage of less than 10%, and actually it's probably about half that, probably about 5-6%, I would guess. It just depends on where people are putting their money on, but certainly I can say, on average, less than 10% house edge, less than 10% disadvantage to the gambler, and yet those dollars are funding a massive city in Las Vegas. So to put that in perspective, if you were to take the very liberal odds that I gave the FBI and the Cooper enthusiast on this particular option number 3, and you were to say they're going to spend all their money, all their time, all their mental thought, all their energy pursuing those 3 options, option 1, 2, and 3, and they choose option 3, and we know what the odds are. They're betting against a disadvantage of 99.92, and if we want to take out the Ingram part, that'd be actually 99.96. So they still think they can solve this case going this route. In Vegas, we have a name for that, and in the next video, we'll talk more about how to resolve this paradox, and we'll see you next time.